Welcome back. This is section 11.9 on gas laws and chemical reactions. This is where this is frustrating for me because I'm on my computer and not on my iPad. If I were on my iPad recording this, I could write, and that's what I want to do. I'm frustrated. So I'm only allowing the explanation that the slideshow gives, which would help you. You can look at the slides and be able to retrace how you do this. But it's not so hard. Okay, it's just knowing the formula, and I only remember one. I remember the ideal gas law, PV equals nRT. Then I solve for one, get everything else by itself, put everything in, and then solve for the new one. That's what I do. Once you do that, you realize that in a chemical reaction, you have a certain amount of material in and a certain amount of material out. If you have reactants that are reacting together to make gases, okay, and you do that, or gases can come together and make things. So you make water by adding hydrogen gas to oxygen gas. That's how you make water. Now the water is a gaseous water, but that water could cool off. It's an explosion, by the way. That water could cool off, and then it just regular water. The Hindenburg, if you've ever heard of that horrible tragedy in the 30s, where a hydrogen dirigible, a blimp filled with hydrogen gas, exploded, of course, in the air full of oxygen, and that fireball essentially was the reaction of hydrogen with oxygen. And what was the product of that chemical reaction? Believe it or not, a lot of water. A lot of water was made as water vapor went out from that as it was made. So when you're using a chemical reaction, you can go through the periodic table to find out how much material you have, then find out how many moles you need, and we do that through the periodic table. And I'll try to explain that, or at least in class, if not here, okay? So the volumes of the amount of a gas can be calculated from the ideal gas law, and then mole to mole fractions based on the balanced equation, and then the molar mass from the periodic table. So let me mention the periodic table first. The periodic table is a cheat sheet of information. There's so much information on it. The atomic mass, which is right under every element, is a number that if you were to take that amount in grams, you would have 1 mole of material. And the mole is an amount. Okay, it's how much. Think of it as a large number. A mole happens to be Avogadro's number of objects. It's 6.022 times 10 to the 23rd power. That means it's a 6 with 21 spaces after it. That's how humongous this number is. It's beyond belief how big it is. Okay, if you were to drop a mole of marbles on the floor, it would cover the entire earth 2 miles deep. That's how big we're talking about in terms of a number. So if you were to have 1 mole of material, 1 mole of gas, 1 mole of phosphorus, 1 mole of hydrogen, whatever it is that you're looking at, it would be equal in grams to the number on the periodic table. So when I say go through the periodic table, the molar mass, it's on the periodic table. And I can go from grams to moles that way. Then I also have a balanced equation that I have. I have reactants, I have products, and I have every number in front of everything. So when you look at a balanced equation, you're going to have the coefficients in front of these formula that have a relationship. And you know, for every 2 of these I make or breaks apart, I'm going to make 3 of these. Okay, so the balanced equation gives you a mole-to-mole factor. How many are breaking apart? How many are coming together? Then the molar mass from the periodic table and the ideal gas law allows you to use the gas law in equations. And I would really think that if you can do this, you're a strong chemistry student, because what you've done is you've organized your thinking. There's nothing really hard about any of it. It's just that you're doing 5 or 10 things at once. You're doing all the things you've learned all at once in one problem, okay? So I'll try my best to help you, and then I will absolutely beam with joy at you if you can do any of them right, okay? So here's an example. What volume in liters of chlorine gas at 1.2 atmospheres and 27 Celsius is needed to completely react with 1.5 grams of aluminum? Okay, so I have 1.5 grams of aluminum coming in. I'm wanting how much of chlorine gas. So I know that there's a 2 to 3 relationship there. For every 2 aluminums I'm using, I'm going to use 3 chlorine gases. So I want to know how many moles of gas is 1.5 grams. So the first thing I'm going to do as I tackle this is turn 1.5 grams into moles of aluminum. All right, so let's see if they do that. I need to start here, 1.5 grams. Then I look on the periodic table, and underneath aluminum, I see this number, 26.98. So I say for every 26.98 grams, I've got 1 mole. So I have 1.5 grams given. I'm going to put grams on the bottom to cancel it, and per mole. And when I do this division, I'm going to find out how many moles of aluminum. I'm going to have 0.0556. Let me go back one slide. So 0.0556 is to 2 as what is to 3. So I'm going to use a ratio. The only thing I ever learned in elementary school was how to use ratios. This is to this as this is to this. So if I know that this is 0.0552 and this is to 2, I can make a fraction out of that and equal it to this one. X is to 3. Because these will relate in the same way as these will relate, and I'll end up with how many moles of chlorine gas. So that's where I'm going next. So I find, this is from the periodic table, 26.98, okay? And when I say there is 2 moles of aluminum for 3 moles of chlorine, I got that from the balanced equation. That means I have 0.0834 moles of chlorine gas, all right? So how many grams is that? Is that what they're asking for? Okay. No, how many liters? I want to go through liters. So I have moles of gas. Well, that's even easier because we know that a standard temperature and pressure, I hope it's a standard temperature and pressure. It's not. Okay. Then we're going to insert all of them into PV equals nRT. So we have 0.0834, okay, of chlorine. Everything else has to go up, so this has to be in Kelvin, so I add 273 to get it in Kelvin, and I'm solving for V, putting everything together, okay. Notice that it was atmospheres, so that's going to give me the 0.0821 R. Fill everything else, and I'll have liters. So what they've done is you need to find out however many moles it is, and then fill it into PV equals nRT. Okay, this is hard. We're in a hard land. This is hard. So what volume of oxygen at 24 Celsius, 0.95 atmospheres, is needed to react with 28 grams of ammonia? So ammonia is made up of nitrogen and 3 hydrogens. So I have to take the number under nitrogen and 3 times the number under hydrogen and add them together. Okay, and that will be 1 mole. That's the number of grams in 1 mole. All right, so that will turn this into moles. So that's the first thing I'm going to do. I need to find out however many moles this is. So 17.03 was these added together. So in 1 mole there's 1703. I want to get rid of grams. So I'm going to put 73 on the bottom. And when I do this, I'll find out however many moles of that is. Now that I have moles, I want to go into PV equals nRT. Okay. First of all, I have to have how many moles of the next one. That's just how many moles of the first. So for every 4 oxygen, there's or 5 oxygen, there's 4 moles of ammonia. So however many moles of ammonia gives me how many moles of oxygen. Once I know how many moles of oxygen, PV equals nRT, and you'll end up with the liters. Okay, so it really is the same way over and over and over again. What mass of iron will react with 55 liters of O2 at STP? Okay, well, STP, there are 22.4 liters per mole. So I need to find out how many liters that is. Okay, it's 22 liters in 1 mole. That gives me 0.26 moles of oxygen. Okay, so once I have oxygen, then I need to know how much I will have of iron. So I have so many moles of this, and I want to come out iron. This is, whatever that was, point something is to 3, as X is to 4. Find out how many moles of this is. Once I know moles of this, I can go into PV equals nRT, and that's when I will be able to find iron. So if I were looking at this video, I would go, ooh, I don't get it, because all of it was written down. It wasn't written down one step at a time. I can do that on the board a little easier, but all of it's here for you to trace it. You could trace the answer if you were to look at this, all right? So giving you what I can, buddies. Thank you.